we have a problem here to find the slope of the tangent line of this cardioid. R is equal to 1 plus cosine theta. This is a polar equation at point theta is equal to pi over 6. So we don't have a direct method to find slope of a tangent of a polar equation, but we remember that there is a relationship between x, y and polar coordinates. X is equal to r cosine theta, y is equal to r sine theta. But we know that r is 1 plus cosine theta, so this can be written as 1 plus cosine theta times cosine theta, and this can be written as 1 plus cosine theta times sine theta. Now we have x and y in terms of theta. That can seem like a parametric equation with parameter as theta, so we can use to find dy by dx is equal to dy by d theta divided by dx by d theta. So let's find dx by d theta by differentiating this with respect to theta. So product rule, what is 1 plus cosine theta's derivative? Negative sine theta times cosine theta plus 1 plus cosine theta times negative sine theta, which is equal to negative sine theta cosine theta minus sine theta times cosine theta by distributing this inside. Okay. Now we know that these two are like terms, so we can just put 2 here and we can erase that, right? So this is our dx by d theta. Let's find dy by d theta also similarly by differentiating y. The derivative of 1 plus cosine theta is negative sine theta times sine theta plus 1 plus cosine theta, derivative of sine theta is cosine theta. That's negative sine square theta plus cosine theta plus cosine square theta. So the slope, for finding the slope, we need first to find the dy by dx. Dy by dx would be equal to dy by d theta, which is this. So negative sine square theta plus cosine square theta plus cosine theta divided by dx by d theta, which is negative 2 sine theta cos theta minus sine theta. We need to find slope at pi by 6. That means we need to put theta equal to pi by 6 in this. So let's do that. Wherever there is theta, I need to put pi by 6. Sine square pi by 6 plus cosine square pi by 6 plus cosine pi by 6 divided by minus 2 sine pi by 6 cosine pi by 6 minus sine pi by 6. Okay. Sine pi by 6 is half, so that is negative 1 by 4. Cosine pi by 6 is root 3 by 2, so that will be 3 by 4. Plus cosine pi by 6 is root 3 by 2 divided by negative 2 times sine pi by 6 is half, cosine pi by 6 is root 3 by 2 minus sine pi by 6 is half. This is basically half plus root 3 by 2 divided by, this cancels, negative root 3 by 2 minus half. You can see that they are same except the negative sign, so they can cancel each other. We will be left with negative 1. So answer to the first question is negative 1. The slope of the tangent to the cardioid at this point is negative 1. So we've already figured out dy by dx for the first part. I'm going to work on the second part now. They say locate the points on the cardioid where the tangent is horizontal. Tangent will be horizontal if dy by dx is 0 basically the numerator is 0. Okay, so for tangent horizontal, we want to check where the numerator cosine square theta minus sine square theta plus cosine theta is equal to 0. So let's try to solve this equation. First of all, I'm going to make it everything in cosine. So cosine square theta minus, in place of sine square, I can write cos 1 minus cosine square theta plus cosine theta is as is. So let's open the parenthesis, plus 2 cosine square theta plus cosine square theta equal to 0. These are, oh, this is just 2. Now these are like terms, so they become 2 cosine square theta plus cosine theta minus 1 equal to 0. That looks like a quadratic, but in terms of cosine theta. But I think we can still factor it in terms of cosine theta. What do you think the factors will be? Let's see. So 2 cosine theta minus 1, cosine theta plus 1. Let's see if that works. 2 cosine square theta plus 2 cosine theta minus cosine theta is cosine theta minus 1 equal to 0. So either the first factor is 0 or cosine theta plus 1 is equal to 0. From here, cosine theta equal to half, and here cosine theta equal to negative 1. So when is cosine theta half? That can be pi over 3, or in the fourth quadrant, 5 pi over 3. Cosine theta is negative at theta equal to pi. So therefore, tangent can be horizontal at these 3 points, provided the denominator is not 0 at those points. But, we also need to figure out when the tangents are vertical. The tangent will be vertical if denominator of dy by dx is 0. That means basically dx by d theta is 0. What is that? Negative 2 sine theta cosine theta minus sine theta is equal to 0. I think I can factor negative sine theta easily because that's in both the terms. What are we left with? Negative 2 cosine theta plus 1 equal to 0. So either sine theta is equal to 0 or cosine theta equal to negative half from the second factor. When is sine theta 0? At 0 or pi or 2 pi. And when is cosine theta negative half? That cosine theta is negative half at the second quadrant, 2 pi by 3, in the third quadrant, which is 4 pi by 3. Now you see at pi is common in both of them, therefore it will become 0 by 0. Dy by dx will become 0 by 0 at pi, right? So there we can't really claim, but other than that, we can claim here that tangent is vertical at 0, 2 pi by 3, and 4 pi by 3. Okay, and here we can claim tangent is horizontal at theta equal to pi by 3 and 5 pi by 3. Okay, at pi though, we will have to separately check the limit of theta approaching to pi of dy by dx. Because it's 0 by 0 format, that's called indeterminate format. This can be done using L'Hopital's rule. I'm not going much into the details of that. But if you use L'Hopital's rule to find the limit of this function as theta approaches 0, that is 0. Therefore, there does comes to be horizontal tangent at theta equal to pi also. Okay. So basically, let's go over it one more time. If you want horizontal tangent, dy by dx should be 0. That means numerator should be 0, but the denominator should not be 0. So we first figured out where the numerators are coming 0. Numerators are coming 0 at theta pi by 3, 5 pi by 3, and pi. But we also wanted to find where the tangent is vertical. Tangent is vertical when denominator is 0, but numerator is not 0. Denominator was becoming 0 at all these points, but pi was in both of them, so I crossed pi because I didn't want it to be 0 by 0 format, right? So all the other points here, tangent is vertical. All the other points here, tangent is horizontal. But at pi, we have to do more analysis using L'Hopital's rule. I can find that limit is 0 and I say that the tangent is horizontal there.